AlcGeomulus Prep Academy, your hub for all things algebra, geometry, and calculus related. Our tutorial today will be finding the total distance traveled by a point mathematically. We're going to be using a few methods to try and figure this out. The first one we're going to use is going to be the table method. If you haven't heard of it, that's okay, we're going to go over it. Then we're also going to use integrals. So let's start off this tutorial by going over what the table method is. So say you have a position function, and you want to find the total distance traveled between 2 points. So what you're going to do is, the first thing is you're going to take the derivative, which is going to be v of t, and then you're going to find the critical numbers by setting v of t equal to 0, and solving. The second thing you do is you create a table of values using the bounds and the critical numbers. For instance, if the bounds are a and b, and your critical numbers, we can represent them as c. We will make a table of a, b, and c. Alright, so to create the table, we are going to have x on one side and x of t on the other side. A and b are going to be our starting and end points, and c is where the velocity of t equals 0, the critical numbers. This is where this function stops. The next step is to create a number line for the function v of t, which is the derivative of x of t that you just took. Now we're going to use this to figure out where x of t is increasing and decreasing. One such graph is shown here. Now, the next step is to draw a figure to display where the object travels left and right. Now let's go over a figure of that right now. It'll look something like this. It'll look like a number line, not unlike the one we just drew. Remember, x of a is the starting point, x of c is the turning point, and x of b is the final point. Now, say x of a travels to x of c, and the number line shows us that's negative distance. That's going to be the negative distance traveled. And then from x of c it goes to x of b. That'll be our positive distance traveled, if that's what the number line we used shows. Now, total distance will be the absolute value of a plus b. Remember, displacement is the straight line distance between the final point and the starting point. And since x of b is our final point and x of a is our starting point, we're going to do x of b minus x of a to get displacement. By now you're probably wondering, so we've talked about displacement and total distance, so what's the difference? So the displacement is the straight line distance between 2 points. But the total distance is the actual amount you travel when you're getting from one point to the other. The last thing we need to go over before we start this unit is the relationship between position and velocity. Now remember, the derivative of the position function is always going to be the velocity function, so that means x prime of t is always going to be equal to v of t. And vice versa, that means the integral of v of t from bounds a to b is always going to be equal to x of t from a to b, which is also going to be our displacement, x of b minus x of a. So our first example today will be finding the total distance and displacement of the position function, p of t equals 4t squared minus 3t plus 6 over the bounds 0 to 5. First thing to do is to find the critical point, so what we're going to do is we're going to set the derivative of x of t equal to 0, since we know that's the velocity. That'll give us t equals 3 over 8. It's going to be our critical point. So now what we're going to do is we're going to make our table. So we're going to put in the numbers 0, 3 over 8, and 5. And when we plug those into the original function x of t, we get 6, 87 over 16, and 91. And we know that 87 over 16 is where it changes direction. Now we're going to find the distance in between each point. We're going to label x of 0 a, x of 3 over 8 b, and x of 5 c. Now, the distance uppercase a is going to be represented by the distance between b and a. So that's going to be negative 0.5625. The distance b is going to be between c and b, which is going to be 85.5625. Now, total distance will be the complete distance a plus complete distance b added together, and that's going to be 86.125 meters. The displacement will be the straight line distance between the initial point and the final point. So x of c minus x of a. That's going to be x of 5 minus x of 0, or 91 minus 6, or 85 meters. So now we're going to use a model to figure out what this looks like. We know it starts at x of a, or 6, and it travels to x of b, or 87 over 16, and then it travels to 91, or x of c. That's what it will look like. The displacement will be the straight line distance between 6 and 91, and the total distance traveled will be the entire distance that particle traveled. We've completed the table method for how to solve this problem, so now we're going to switch back to the integral method. Now remember, our original function was x of t equals 4t squared minus 3t plus 6. Now we went over earlier that velocity is equal to the derivative of x of t, so that's going to be 8t minus 3. Now, to get total distance with an integral, you gotta take the absolute value of the velocity function from points a to b. Now, we know our bounds are 0 and 5. So when we plug in v of t and our bounds, that gives us 0 to 5 of absolute value of 8t minus 3, or 86.125 meters, which is the same that we got earlier. How cool is that? Now we'll do the displacement. Now to get the displacement, the formula is just to do integral of a to b of just v of t without the absolute value of v of t. When we plug in our numbers, we'll get 85.0 meters after plugging that into our calculator. Awesome work, class. Let's do our next problem. Next, we'll be finding the total distance traveled in the displacement for the function x of t equals 7t cubed minus 8t squared plus 1 from the bounds -1 to 4. So we're going to start with the table method. Since we know the derivative of the position function is a velocity function, we'll take the derivative of x of t and get 21t squared minus 16t. So, to find the critical points, we're going to set v of t equal to 0. And when we separate t from 21t minus 16, that will give us the critical points of t equals 0 and t equals 16 over 21. Now let's make our table. So, what are we going to include in our table? That's right, we're going to include -1, 0, 16 over 21, and 4, because those are our critical number and bounds. When we plug those into x of t, that will give us -14, 1, -0.548, and 321. So we know that the top and bottom values are the start and end points. At the critical points, we know the object changes direction. Now we're going to find the distance in between each point so we can calculate the total displacement and the total distance. Now, in distance a, between x of -1 and x of 0, we have 15. In distance b, between x of 0 and x of 16 over 20, we have -1.548. The distance between x of 4 and x of 16 over 21 is going to be 321 minus -0.548, which is going to be 321.548. That means the displacement, which is going to be our final point, x of 4, minus our initial point, x of -1, is going to be 321 minus -14, or 335 meters. The total distance will be the sum of all of those and their complete magnitude, so that's going to be 338.096 meters. So now we're going to work on our first diagram. So, we know that it starts at x of -1 and then goes from x of -1 to x of 0 to x of 16 over 21 to x of 4. So, here's a rough scale model of what it's going to look like. We know it starts at x equals -1, so we're going to draw our first point there, and we know that exists at -14, and then goes to 1. So that's a positive change of 15 meters, right? Great. Okay, so then it goes from x of 0 to x of 16 over 21, which is a negative number, so 1 to -0.548. And from there it goes from x of 16 over 21 to x of 4, or -0.548 to 321. This means that the total distance is going to be the sum of a plus b plus c. The displacement will be the distance from x of -1 to x of 4, or 321 from -14. Now let's do the integral method of this problem. Remember, our original problem was x of t equals 7t cubed minus 8t squared plus 1 with the bounds of -1 and 4. That means the derivative, or our velocity, is going to be 21t squared minus 16t. If you remember our total distance integral formula, it's going to be from the integral of a to b of the absolute value of v of t of dt. The displacement is going to be the same thing except without the absolute value, because we're getting the distance from a to b. This means total distance is going to be the integral of -1 to 4 of absolute value 21t squared minus 16t, and after we put it in the calculator, that's 338.096 meters. Displacement will be the same thing but without the absolute value. When we put that into our calculator, we're going to get 335 meters. This concludes our final example for the day. Thank you so much for joining us here at Algeomulus Prep Academy today, and we're so excited to share with you our next tutorial. Please like and subscribe, and we'll see you next time. Enjoy your math, and have a great day.